Welcome to week 2, Introduction to Chemical Engineering. What we're going to do this week and next week is really concentrate on chemistry. In particular, if you remember from the introductory videos, we're going to talk about a little bit about fuel, in particular gasoline, diesel, and so forth, and also light-sensitive materials that are used in cameras. But this week, we're going to concentrate on fuel, in particular the combustion of fuels and the relationship of the combustion to mechanical energy and so forth. Okay, so we're going to start with the fuel. We're going to ask the question, we're going to look at the process of what's called combustion or oxidation, burning the fuel with oxygen and the energy change. And then ask the question as to the role of the engineer in making the fuel, using the fuel, and so forth. So that's our objective for this week, and as we move next week. Okay, so we're going to look at combustion reactions. Okay, the fuels we're going to talk about are things like gasoline, diesel, natural gas, talk a little bit about coal. And the key thing that links them all together is that they are compounds made primarily of carbon and hydrogen. And so when you combine that with oxygen, you form carbon dioxide, water, and importantly, you create the energy that you need to move automobiles, trucks, and so on and so forth. Okay, so the chemistry. The chemistry we're going to talk about is something called oxidation or combustion reaction. So how does a car move? We burn a fuel, in this case, say gasoline or diesel somehow, in a chamber, the confined chamber, and that creates essentially the energy to move the pistons, right? So where does that energy comes from? Where's that energy from? And it comes from the combustion reaction, which results in the creation of energy from the energy inherent in these fuels. Okay, so the concept, we got a few of the concepts in chemistry we're going to look at are things like balancing of chemical reactions and then calculating the energy change because of these chemical reactions. We'll take a little look at the states. For example, we all know gasoline is in liquid form. Natural gas, as you would expect, is gas. There are some consequences to using gas or liquid as fuel. The engineering aspect of it is, where does gasoline come from? Primarily from crude oil, which is obtained by essentially mining it from the ground. And then there are also some additional chemical engineering things that are done to reduce the size of these larger molecules into more smaller and therefore more useful molecules using a process called fluid catalytic cracking. We'll introduce you to that a little bit. Okay, so let's take a look at the chemistry. Fundamentally, the oxidation of the fuel in a confined chamber creates the heat, expands the gases, and provides the mechanical energy for the pistons to move. And so to put it very simply, fuel plus oxygen, you find a way to burn, essentially burn them, right? Burn the fuel somehow. It creates oxides of carbon and hydrogen. And because of the high temperature, it also creates oxides of nitrogen. And more importantly, generates heat. So you can imagine in a confined chamber, a fixed amount of, say, air, for example, if you create heat in there, that air is going to expand along with the new gases that are actually formed, creating mechanical energy. And one simple way to understand is that in a given volume, if the pressure increases, therefore, the temperature will increase. Or if the temperature increases because of heat generation, the pressure will increase. So one way to relieve the pressure is through the mechanical energy transfer process of moving the piston. So this is a simple equation to understand the relationship between temperature and pressure and volume and so forth. Okay. And at the bottom, and you can find a lot of these in YouTube and so forth about how a gasoline engine works by creating the energy in a confined space. Okay, so we're going to talk a little bit about chemistry. And as a little bit of a fun thing, I've drawn a structure over here, and then see if you can take a look at what this structure might be. This is something, a hint is, this is something we a lot of us consume first thing in the morning, if you will. One of the very interesting chemical compounds. See if you can guess what it might be. Okay, so let's start with the concept of balancing of a chemical reaction. And what we're going to do is, step by step, ask the question, the relationship between a hydrocarbon, the oxidation process, the creation of the products of the oxidation, and a way to calculate how much energy we might be getting from, say, burning one molecule or one mole of a particular fuel and so forth. So we're going to look at the equation balancing a little bit. Okay? Now I want to make define something. I want to define something called enthalpy. You don't need to understand a lot of details about it, except to know enthalpy is a measure of the energy content of a molecule. Higher the enthalpy, higher the energy content it has. And as you will notice later, we're going to have positive or negative enthalpies. And if in a given reaction we add up all the enthalpies, we get a negative enthalpy, that means by convention energy is actually released because of the reaction. But there are the convention could be differently interpreted also. We're going to use the negative enthalpy, means energy is generated. Okay. So what we're going to do is write chemical reactions. We're going to add up the enthalpy of the products, add up the enthalpy of the reactants, subtract the two, and ask the question, what is the difference? Okay, that's going to give us an idea of the measure of the amount of energy that is released because of the combustion reaction. And again, this is also something you don't need to worry about, and this is something we'll deal with as we move forward. There's something called a standard state, where the enthalpy of the compounds is actually 0. Stop there.